Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to look at the topic and combustion, and we are going to continue discussing on burning substances in air. Previously, we talked about burning metals in air. We looked at different metals that were burnt in air. We looked at their products and also how their products are dissolved in water and what they form in regards to the litmus paper. Today we said that we're going to look at burning nonmetals in air. So what happens when you burn these nonmetals and the product they form? How can you be able to test those products that they form? So we will start with sulfur. Sulfur is usually a yellow solid, and it usually burns in air with a blue flame. And when it's burnt with a blue flame, it gives a colorless gas. This colorless gas has an irritating, choking smell, and this gas is referred to as sulfur oxide. So this equation, when sulfur reacts with oxygen, it gives sulfur oxide, and this is the chemical equation. You can see sulfur oxide is also written like this. You're going to discuss outright this chemical equation later on in Form 2. And this product, when you dissolve it in water, it forms sulfurous acid. This sulfurous acid is acidic in nature. And how can we tell this acidic in nature? This is because it dissolves, or it turns red litmus blue litmus paper red. It turns blue litmus paper red, and red litmus paper remains red, which tells us that it is acidic in nature. Next, we are going to look at carbon. When you burn carbon, carbon is commonly known as coal. It's the charcoal that we use, the one that you see around. It's also known as coal. And you notice it's usually black in color. So if you burn that carbon, it glows red, like when you burn it in a charcoal jiko. And when it glows red, it gives a colorless gas. This colorless gas, if you bubble it in a jar or in a test tube containing lime water, it's going to turn to a white precipitate. And the moment you see a lime water turning to a white precipitate, it tells you that carbon dioxide is being produced. So the product of burning carbon in air is actually carbon dioxide gas, and this is the equation: carbon burns in oxygen to form carbon dioxide. So when you take this product and you dissolve it in water, it is going to form a weak acid referred to as carbonic acid. How do we know that it is an acid? Because it turns blue litmus paper into red, and red litmus paper will remain red. So what happens if we burn this carbon in a limited supply of air? If we burn carbon in a limited supply of air, it undergoes partial oxidation. This means that some of the carbon particles are not going to react with oxygen. Only a few of them are going to react. And when that happens, it forms carbon 2 oxide. Carbon 2 oxide, or commonly known as carbon monoxide. This is the equation for the reaction. You're also going to be required to know how to write the equation and balance it. This carbon monoxide we are going to discuss later in Form 2, and how dangerous it is, especially to the human system. So later on we are going to discuss that. Next, we are going to look at phosphorus. So phosphorus burns with a white flame. You remember we talked about the smoldering phosphorus when we were discussing about the active part of air, and we said that phosphorus burns with a white flame to give white fumes. These white fumes are a combination of both phosphoric 5 oxide and phosphorus 3 oxide. It is a mixture. In the same way we were saying that magnesium forms magnesium oxide and magnesium nitride, this mixture is the one that is the white fumes, phosphorus 5 oxide and phosphorus 3 oxide. Both of them, when they are dissolved in water, they actually dissolve in water, they form an acid. We call it phosphoric acid. Phosphoric acid. So how can we form phosphorus 3 and phosphorus 5 oxide? So when we have excess oxygen in the gas jar, we form phosphorus 5 oxide. It is dominant. And when there is a limited supply of oxygen, phosphorus 3 oxide is produced. That's why there is a mixture. There is an instant where the amount of oxygen in the gas jar is highly concentrated, and then in the course of the reaction the amount of oxygen reduces. That is the reason why phosphorus 3 oxide is produced and also phosphorus 5 oxide is produced. You can note the equations for this reaction. You are required to see the difference. You can see phosphorus 3 oxide and phosphorus 5 oxide, the formulas. So when these both are dissolved in water, we say that it forms an acid which is referred to as phosphoric acid. This turns blue litmus paper red, and red litmus paper remains red. And remember, this litmus paper must be moist. Either the fumes are dissolved in water first and then a strip of the blue litmus paper is used, or if the gases themselves, they can you can put a wet blue litmus paper in the mouth of the gas jar. You're still going to get the same product. So let's look at one question in regards to what we have been discussing. Moist, damp or wet, it can be used alternatively. Blue and red litmus paper. So we both have the two litmus papers were put in a gas jar containing air, or in this case, because oxygen is the active part of air. Burning magnesium was then lowered into the gas jar. State and explain the observation. So we are stating the observation. What did you see? And then why did that observation occur? So this burning magnesium was lowered in a gas jar containing oxygen. So one of the observations that we are going to notice that sulfur is going to burn with a blue flame and a colorless gas is going to be given off. So those are the two things you notice: blue flame and a colorless gas is given off. Explain. So the blue flame is because sulfur burns in air with a blue flame. The colorless gas is a product. Sulfur burns in air to form sulfur 4 oxide gas. So this sulfur 4 oxide, remember, our litmus paper is the main concern. So the blue litmus paper and red litmus paper, we know that the blue is going to turn red and the red is going to remain red. This is because now this sulfur 4 oxide that has been produced, when it reacts with the wetness or the water on the blue litmus paper or the red litmus paper, it formed sulfurous acid. This is the acid that turns wet blue litmus paper red, and the red litmus paper remains red. So you are able to explain where the product is coming from. Sulfur is burning in air, and then the product is reacting with the wetness or the water on the litmus paper, hence causing that change in color on the litmus paper. I hope you have been able to understand this question and also the products of burning nonmetals in air. So see you in the next session.